Hi, everyone, and thank you for joining me in the missing piece of cloud security. Now, to be honest with you, it actually took me a moment to come up with what picture I was going to use for this, because if you look at it, right, it's this beautiful, just day, and you're going to go out and you're like, wow, blue skies. And how many of you would go, wait a minute, like, what happened to the clouds? Yeah, that's how dorky I am, and that's just how dorky this is going to be. So I hope you enjoy this ride. I guess I should go ahead and introduce myself, though. My name is Marquez, and I am the Linux and security advocate at Inazur. Now, I know that's a bit of a weird title. People are always like, you do what now? And maybe it's unique, but I love my position because what I do is I work with our research team and my friends who are researchers and companies which we collaborate with, basically any researcher who's willing to sit down with me. And I dig into their findings. What are you working on? What did you find? And then I just keep asking questions. What does that actually mean? How does it relate to what we're doing? How does it relate to, and more questions until I'm able to refine it into information that's easy to share, but actually has actionable steps that you can take and implement into your environments, implement into your companies to increase your security posture. It's a lot of fun. And along with that, I am an advocate for hacking is not a crime. So you always hear me say cyber criminal, not hacker. We're all hackers. We're all having fun with this and inventing new things. And one thing that I'm very proud of is that I'm an advocate for Operation Safe Escape. We're a 501c3 helping victims of domestic violence who are being targeted by their abusers with the use of tech. So if you or someone you know is in this situation, please reach out and know that you're not alone. Okay, let's take a deep breath after that and go on to our agenda. Okay, so our agenda today is going to be a bit long, but you know what? All of this is important. And so first, we're going to start out with cloud compute security challenges. Then we're going to talk about security challenges when it comes to the cloud providers themselves. Then we're going to go beyond the abstract. You're not really here to hear a lot of theoretical, and it could be, and it has been. You're here to find out like what is happening now. Then, of course, we'll have the big reveal. I mean, that's why you're all here for, right? Then, like I said, I'm going to finish off with actual actionable security suggestions for you. And suggestions, I mean, go and do this. Then I'll wrap up with questions. And please feel free to ask them. I am cramming in what could be 4 hours worth of information, trying to condense it down. And don't be afraid of asking anything that's a technical deep dive. Like I said before, I work with researchers. If I don't know the answer, I can get them for you. Let's get this party started with cloud compute security challenges. This is a critical part of cloud security because what is it that you're trying to protect? And if you tell me your environment, I can tell you you're already doing it wrong. It's like taking your car in for maintenance because something isn't working, and the mechanic says, okay, what are we working on today? And you say, the car, and walk off. That just leads to more investigation, more work, and honestly, more than we can probably have time to do. So I ask you, what is it that you're protecting? You're protecting your workloads. Yeah, you have firewalls and you've got your environments that are built out with different availability zones and different. If you're worrying about protecting those things, then you're losing sight of the big picture. You're there to protect your workloads, your applications, and your customers' data. And these all happen within your compute resources. But in order to understand what the critical issues are here, we actually have to go back in time. And we're going back in time quite a ways. We're going to 1985. And if you're one of the newbies in tech, you're going, wow, that might be before I was born. But okay, 36 years ago, we had the advent, the release of Windows. Ooh, right? Windows was, it was, what is the word I'm looking for? It was kind of just, it was groundbreaking, right? It brought computing, it brought computers to anyone who really wanted to use them. As it kind of, evolved, it made it easier for anyone to be able to use computing powers. It was put into schools, it was put into companies. And so it became the operating system that everyone was familiar with. Makes sense that now it's actually 85% of the market share, in 2020. Let's go to Linux though. Linux kernel version 1 was released as a side project in 1991. Now, I'm not talking Linux, the operating system. I'm talking Linus wrote a bunch of code, threw it together, met his needs, sent it out to a mailing list, and was like, I don't know if this is going to help anyone else, but it's here for you to use. Feel free to change it. Feel free to do whatever you want with it. Turns out people could use it, and it continued to grow. But we didn't actually get the first Linux distribution until Slackware in 1993. There is a big gap. So when it comes to computing and what people are familiar with, Windows has this heavy history where Linux is still seen as the little baby in the industry. Many people aren't familiar working with it. Just a side note though on how cool Linux is. Yeah, I'm a Linux user if you can't tell. You know Yoda? Yeah, Yoda in all the new movies. He was created using Linux. Just throwing that out there. Linux though really kind of got on steroids, to be honest, and grew up and really became a contender in the operating system world when it came to the cloud. Now, I love this image. If you ever meet me in person, ask me to see my tattoo. It's about this big and this wide, and it's this exact same image. Side note, if you're hearing my dog bark, I'm sorry. Welcome to the pandemic. When it comes to Linux in the cloud, now in 2021, it makes up 96.3% of the world's 1 million top servers and 90% of cloud infrastructure. Now, I'm willing to go out there and say, you know what? Linux is the cloud. The cloud is Linux. When I heard that over 50% of Azure, that's right, Windows, Microsoft's cloud is actually running Linux, we got to the point where we know it's going to be hard to beat. In fact, Microsoft CEO Steve Ballmer, and I'm really hoping I'm saying that right, has said in 2001, Linux is a cancer that attaches itself to intellectual property sense in everything that it touches. No hard feelings there, right? However, as Linux grew in popularity, they had to do a bit of backtracking. Now, this was released in 2014 with Microsoft's new CEO saying, Microsoft loves Linux. What does this have to do with compute security? There it is. Linux security is cloud compute security. Without becoming familiar with the Linux operating system, it's going to become extremely difficult to become comfortable in the cloud. And with people having more experience within the Windows environments, that transition is a stark one. And with companies going all in and just saying, all right, workloads are now on cloud, we're doing this deployment now, we're doing this move now, who's taking the time to give the security teams, the developers teams, their ops teams, the training that they need in order to be able to secure these environments better? There's a lot of visibility missing when it comes to the actual planning of it. We're just kind of thrown into the deep end and said, hey, secure it. There's big issues here, big holes that really need to be addressed. But that's not even, I guess, the biggest hole that I'm seeing, kind of the biggest issue, but not the biggest hole, because when do we think about cloud provider security challenges? Like, when is the last time you invited your cloud provider to have a nice cup of tea, sit down, and talk about their security posture? What is it that they're doing to keep you safe? Hey, have you been breached recently? What did you do about that breach, Azure? What did you do about that breach, Google Cloud? I'm going to pick on the top 3 just because it's easier than going after the small cloud companies. We're hoping that they take off well, so I'm not going to pick on them too much. The issue is that the cloud itself is ephemeral by nature. And so it's constantly changing. There are constantly new servers and new providers out there. They've got their own release cycles. They've got, oh, this is the new hotness. We're going to introduce this and it's going to take this service away from here. And once again, you're losing the insight to what's actually occurring. And without having these conversations, without understanding what the cloud provider is actually offering you, how can you even say that you have security posture? And the one thing I always get is they're like, oh, you're making too big of a deal with this. This is a really simple answer. I mean, they even make a chart for it. Who hasn't heard of the cloud responsibility model? Simple, right? AWS, Google Cloud, whatever, picking on them because they made this image. AWS is responsible for the actual protection of the cloud. And you're responsible for everything in the cloud. That's it, right? It's really easy to understand. I mean, when it comes to the operating system, well, that's obviously like in the cloud, right? So that's me. But if it comes to storage and databases, that makes up the cloud, so that's them. But what if I'm running hold on. It actually does get confusing. And what I end up referring to this, if this is how you believe that your security agreement is with your cloud provider, I end up calling this the cloud irresponsibility model, because it's an extremely irresponsible stance to have. I want to know, I did not coin this term. And if you know who did, if you know who coined it, there you go. Please let me know. Like, I would love to give proper attribution. The reason that it gets confusing is, hey, then we have all our as models, right? There's a joke to be made there that I hope that you all got. There's, infrastructure as a service, which tends to line up more with that, right? We've got our virtualization, and then we're in charge of our OS and our middleware. But wait, there's also platform as a service, which means they then have the operating system in the runtime, but I thought I controlled what was in the cloud. And then they have software as a service where they just own everything. And what if I'm going to pick on marketing. I pick on a lot of different teams. Hopefully everybody just has fun with it. I pick on marketing. Marketing is using all software as a services. They're using Google, they're using Gmail, they're using Dropbox, they're using Asana. And then our developers are really doing quick deployments, and they're using a lot of platform as a service. And we also have a lot of our infrastructure as a service running, some of our antiquated or older applications. Security team, what are you protecting? Like, do you know exactly where all of your assets are, what teams are using what you should be monitoring, what's the most important thing to be monitoring? Hey, we've got security campaigns that are running for marketing, but at the same time, we need to do security checks for our developers as they have their deployment cycles. And who's still using this old server that we have set up over here that we paid for? Should we even be monitoring it? I'm running out of breath and probably speaking too loudly because it does get very overwhelming when it comes to actual practice of it. I've spoken to a lot of different companies. I've done a lot of lunch and learns and presentations like this where I ask the question, do you actually know every single thing that's on your system, every single thing that's in your environment, in your cloud, in your hybrid cloud? And I get a lot of just smiles and nods and no. I had one guy that told me that he did, and then he also told me that they're only running about 3 servers. So, you know what, fair. If you have a much wider environment out there and you can tell me that you know every single thing that's there, every single thing that's running in it, I'd really challenge you to go back and take a second look and a second thought about this. Okay, so we also need to remember that relying on the cloud security model or relying on the cloud providers really isn't enough. But with everything that I just said, we have 78% of organizations saying that they're really unsure where their security responsibilities fall. Most importantly, and if you're off doing something else, like listen to this part, the buck stops with you. If I am trusting you with my information and you're breached and it's out there, I don't care what cloud provider you were using. I don't care that it was their fault. I care that I trusted you with my information, and now because of what you did, it's out there. This is a lot of responsibility for security teams. I mean, if an application gets breached, really, where does the buck stop? Do they go, developers, how could you have let this happen? Or do they say, security, what happened? Why did you allow this attack to occur? Why did you allow this attack to be successful? Then, like I said, we have the hybrid cloud deployments. Security products, when it comes to the cloud, are constantly shifting. So if you have, a little bit like, I don't know, your containers inside of GKS and Google, because that would be the simplest. And I have my AWS EC2 web servers running, and I've got my cloud, my actual databases on-prem, and you're doing something else with Azure. I don't really use Azure often. How are you matching up your security services? Like if Google offers one service with A, B, and C, are you sure that the other 2 providers do as well? Or are there 2 services that you need to be relying with? And have you configured those correctly? Have you had the conversations? There's a lot of just darkness, a lot of unknowns when it comes to having your only relying on the cloud providers. And I've already spoken about some of these, right? You have your rapid deployments. Are we actually keeping up with the tools as quickly as our developers are needing to change environments? Developers, I love you. I'm not picking on you. I understand that there is a lot of this that's just being put on you. And then we hit containers. All right, now we've gone from rapid deployments of every few minutes to every few seconds inside of the environments that are deploying every few minutes. I don't know about you, but honestly, I don't know how most people do it because I ended up feeling when I was doing all this insanely overworked. Like I was just under a mountain that I'd never get past. One thing that people do not think about, and you seriously need to know this and think about it and put it in your plans, is the fact that cloud providers, they're being targeted as well. The Department of Homeland Security, CISSA, I forget all the acronyms, basically big security organizations within the US government, as well as some within the Australian government. And I'm not going to dig into every country. Governments are letting you know, starting in 2014, that they are seeing advanced persistent threats specifically target MSPs. It's gone as far as in 2021, September 3rd, and I'm going to have a resource page up. I'll share this with the organizers, put it on my slides. It's lopunk/BSides, Lord, I forgot for a minute, /BSides Charlotte. I don't know where I am these days. We'll get it to the organizers. Anyways, I will have links to the actual documents that are out there. So anyways, okay, so they're putting out all this documentation and all of these notices that say, right, September 3rd, hey, it's not they are targeting, it's they have targeted, they have been successful, this is what you need to do. We're gonna see the growth of this. One thing that has changed because of this is now we're seeing advanced persistent threats becoming less specific. Like, I am targeting only company A. They get into the MSP, they get company A, but hey, you know what? Here's a crime of opportunity because I have company B, company C. So even if you don't think you are a company that would become that target, you could just become a target of just availability of opportunity. So you need to have that in mind. All right, we're about, I don't know, 15 minutes in at this point, if my ability to rehearse this counts for anything. And you're probably going, okay, a lot of theoretical, hopefully you're saying some good information, but back this up. Like, what are you actually seeing when it comes to research and, attacks? So let's go into the attacks. One of the attacks that's currently really in the news and really making headlines right now is Cloud Snooper. Now, Cloud Snooper was actually detected by Sophos, so great work on their researchers. And they did it while they were investigating malware that had, basically a malware infestation, I'm gonna go with that, on cloud infrastructure that was hosted on AWS. Like, this is not AWS specific, though. I need you to understand this. It could happen on any cloud. It could happen on your OpenStack build that's on-prem. So don't tune me out if you're just, going like, oh, I don't use AWS. This was an extremely sophisticated attack that was employing unique combinations of techniques that, they hadn't seen before. It enabled them to evade detection and really provided the ability for the malware on the system to be able to communicate freely. The issue here is that the servers that it was able to compromise and was working within were properly secured. The firewall rules were great. The security groups around them were great. And I love how Sophos explains all of this because they explain it to me literally like I'm 5. All right, so I'm not going to walk through all of this. I'll make it, available for you, but it's entertaining enough that I'd like to spend a little time on it. So we've got our castle, right? Our castle's our environment. It's fortified. It's all around our web server. The image is over here if you see me looking at it every once in a while. And we have both of our knights there, right? And our knights are going to be our firewall rules. They're configured. They're ready. You see the closed ports, the gates. They are ensuring that only the HTTP packets are coming in. But there's something scary here, right? Look, there is a wolf in sheep's clothing. This isn't going well. And inside the castle, there's already a rootkit installed. There's already a backdoor that has been taken advantage of. Goes to the concept that you should always assume breach. We can build all of the walls that we want to, but at times we're just building a wall around the attacker that has already gone into our system. Then, the C2 traffic is able to throw off its wolf, its clothing, show its actual face of being a wolf, and run away with our sensitive data. And you see that at the bottom with the little wolf that says exfiltration running away with his 2 chickens. I love learning like this. Hopefully you look at this and can just kind of go through it and, it becomes granular. All right, away from my comics, I enjoy this way too much. Let's go into the actual code itself. Now, when I started looking at the Cloud Snooper malware, and believe it or not, my company actually trusts me to play with real malware. I don't know what's wrong with them. I was able to see two different variants that I had abilities to look into. One was detected and found and uploaded in February 26th. And if you look at the very end of it, I should have highlighted these, you see that when it was run through VirusTotal, only 17 out of the 58 search engines were actually able to detect it. Now, this was after it had already been made public. This was after, we'd already had news story, Yara rules were released. Like, this should have been something that we were prepared for. However, that traditional endpoint protection, those traditional antivirus programs that we've been used to using on-prem are not transitioning well when it comes to cloud environments. And then we go up to April 4th, right? That's a bit of time. Well, you know what? If you look a little closer, the SHA has changed. And that's because, like attackers, they know what they're doing. They know when something has been released that we're going to start looking for it specifically. So they start manipulating their code. They start changing things in order to be able to bypass our anomaly or signature-based detection. So I'm going to dig in a little bit deeper. And you see my first one that I looked at was Cloud Snooper and malicious libraries. Okay, I mean, it's what you would expect. Like 97% of the code was written to do what we expect through Cloud Snooper. And obviously they're going to implement malicious libraries. I mean, they're not going to write every single thing from scratch. Like developers, I love you all, but we're lazy, right? There are front-end developers, back-end developers, and Stack Overflow developers, as Corey Quinn likes to say. We reuse code whenever we can. Then I went in and looked a little bit deeper into the next piece of malware that I had access to. We start seeing new things implemented, like Rakobi. I never say any of these things right. Functionalities from the code that had made Rakobi successful were being brought into the Cloud Snooper code. This is something that they're able to do in order to make their malware more effective, make it be able to target a specific target in the way that they want to. So it's not just pray and spray, it's this is the end goal that I want with target A, therefore I'm going to bring in specific attributions and specific abilities that I want to. Okay, so there is a brand new thing that we need to be aware of, right? Custom made, even with a little bit of code borrowed, malware specifically designed for the cloud. But we don't even have to go that advanced. It doesn't have to be that unique, because one of the biggest issues, if not the biggest issues when it comes to compromise, is it happens because of misconfigurations. To the point where, and I believe this was Gartner, I will look up the source and ensure that I cite it correctly on our resource page, that 99% of cloud security failures through 2025 will be because of the customer's misconfiguration. We're human, we are fallible, we make mistakes. And yes, even security professionals, you're high level, you're insanely well paid, you're gurus of security, they make mistakes too. We had what I would hope is to be some very strong, very able, very intelligent cloud security and security professionals that worked for the Pentagon release 100 gigabytes of data. Now, this data was compiled from a joint intelligence program between the US Army and the National Security Agency. Might have been some important things there to protect. And you might say, okay, mistakes were made. It was available for what, an hour, a day, a week? Yeah, it was several years that this was available on. A way that we're seeing attacks kind of change because of this, really targeting that misconfiguration, is one of the malware that's actually my favorite to show, because it's actually not that difficult for the attacker to do. See, this malware was called Docky. And Docky is specifically targeting Docker containers, or is targeting Docker containers in environments that have open Docker API ports. Now, when it was discovered, it actually had 0% detection on VirusTotal. And at this point, having worked in this field long enough and talking to researchers, that doesn't even make me blink at that point. 1%, 0%, to me, that's the norm. That's what I'm seeing all the time. And that should scare you so much. If you're relying on those, endpoint protection, the traditional antivirus, and I keep telling you that it has 0 detection or 32 out of 58 after months that it's been out there, that's a wake-up call for you when it comes to your cloud environments. Now, one of the cooler things that Docky did, okay, look, it's bad that they're compromising, it's bad what they do, but if you're looking at the code and the abilities, it's pretty cool. And that's because it was able to bypass all pre-runtime scans, right? All your container scans, all your image scans, because there was absolutely nothing malicious with the image itself. It was all perfectly well and good. What it did, though, is once it was launched onto a victim server, it was able to use the curl command. Now, look, as an admin, I can tell you curl was probably used daily in order to help troubleshoot. So it's going to be on a majority of servers. And it called out to its C2 servers, and it pulled down the malicious content, the malicious packages that were enabling it to actually break out of the container and own the host. All of this happened in the matter of seconds. Can you actually say that you as a security team would have the visibility in the moment to see that one container go up, go down, and be gone? Like, we are so overwhelmed with the amount of environments that we have, with the amount of deployments that are happening and changing because of this new cloud infrastructure, that we have some protection for our containers. Like, we know what's going into them. We have our pre-run scans. We're looking at the code. But it's not enough. It's not enough visibility into what's occurring for us to be able to do our jobs properly. Now, because we found Docky, I had a few more samples that I was able to play with. And let's take a look at this one, right? It's from January 14th. This is the best detection rate that we could have gotten. If you look at the others, right, we're at 32 out of 58 of these. Now, I reran this scan 2 days ago. I'm recording this on the 14th, 2 days ago. And okay, we got better. Like, we have a few more. That was over a year ago. This information has been out there. We haven't kept it, secret. We've sent out the YARA rules and, signatures and indicators of compromise to everyone that we can, and we're still looking at this low detection rate. Once again, am I setting off the alarms for you on how security needs to change when it comes to the cloud environments? If not, let's look at things by the numbers. In 2020, we saw an increase of 40% new Linux malware variants, new Linux malware. I apologize for using 2020 statistics. We have yet to release 2021, and most organizations that I know of haven't either, so I can't even quote other research teams. And between 2010 to 2020, we saw a 500% growth in Linux malware. And you'll be saying, you know what, I keep my systems up to date. Don't worry. Every time there's a signature out there, I'm not one of those. I've implemented it. Our databases are as best as they can get. Really? Because there's about 560,000 new pieces of malware that are being seen every day. And you know what? Maybe some malware some days are some days are better, some days are worse, some days the malware developers are, having a bit too much coffee. But it averages out to about 17 million new pieces of malware each month. Are you really updating all of your security posture, all of your security devices, really your signatures and your anomaly-based detection, to actually look for all 17 million of these every single month? I really don't think so. Even if you told me you were, I'd still be hesitant to believe it. We're about halfway through this, I think, and so it's time for the big reveal. Yay! All right. Okay, maybe I didn't need to go with this ugly pink on blue. I mean, it's not a gender reveal party. But on the plus side, we are not going to catch an entire forest on fire or any of the other fun things we've seen on YouTube. So I ask you, are you ready? Are you really ready? What is this missing piece to our cloud security? I feel like I should have a drum roll or something. But okay, I'm guessing if you were listening, you probably, hopefully already know. And the missing piece is simply visibility. Hopefully you're not let down. Really, that's what's missing. If you've heard me go through all of this, the issues with visibility is we don't know. And to a certain degree, sometimes we don't even know what we should know. And it's extremely difficult to protect something that's abstract. I'm going to protect myself I'm going to protect what's in the darkness, even though I don't know what I'm protecting. All right, let's go into the concept of visibility. The big questions that you need to be able to answer is, first of all, what's in your cloud environment? Now, I've gone through that several times and kind of made out a list, but truly sit down, find some time, because this is extremely important. Find, whatever application, if that's what helps. Obviously, like, I'm not going to pitch my company, but it's one of the reasons that I know about this is you need to know not only what resources that you have on it, but you need to know what is actually running on those servers. Like, hey, I've got 2,000 EC2 instances. Are they all needed? Are they all running code that we actively need, or did somebody just forget to delete something? We have multiple cloud deployments for an application that we used to run 2 years ago that we deprecated and nobody remembered because that developer or that person left. Then where is it running? It was quite interesting to talk to people and say, like, okay, what are you protecting? Customer's data. Where is it located? It's located in databases.l. Okay, but where is it located? Like, where do your databases reside? It seems like an obvious question, but a lot of security teams don't actually know. They rely on ops. They rely on other sides of the house to keep track of that. They just say, I'm protecting our DBs. What if we had something that was specific to a vendor that occurred? For example, we recently hacked Azure Functions. If you didn't know that your teams were using Azure Functions, maybe you wouldn't have been as concerned about that. And then, where is it being stored? Like, and kind of that is, where is it running as well? So just pull that in together, sorry. And really, who has access to it and who should have access to it? Once again, these seem, it would really help if I was pushing the button so that you all could see this. So this seems like an obvious statement. Like, yeah, we know that, that's obvious, but we're not doing it correctly. I can tell you that I worked for a major cloud provider and I was really lucky. Hopefully I was doing well. I was getting promoted and moving around to teams, and I always got the permissions that I needed to be able to do my job. I don't think I ever had any other permissions taken away. So even though I was working perhaps on a completely different side of the house, I could still log on to all my old accounts and actually was quite often asked to help other teams. It might have been helpful, but this is something that should not have occurred. On top of that, when I left the company, I left on good terms, everything was good. I hadn't signed out of my company email and stuff on my phone. I still had access to it like 3 days after I left. I'm the one that actually took it off my phone, so I don't know how long it took for them to realize that I still had access to something. What if I'd been a disgruntled employee? What if I believed and just kind of acted like I'd left on good terms, yet still had access to everything? Not only that, but you know what? Accidents happen. It doesn't need to just be a malicious actor that's having access to it. One thing that we saw, and I don't have it in my notes, but I actually think it's very interesting, is malware by the name of Evil Gnome. And people kind of get annoyed with me when I talk about it because they're like, it's not about the cloud. That is like completely desktop based. But as a Linux admin, and a lot of the security people that I know, we run Linux as part of our day-to-day. What if my system after I left, because I'm not, working on best practices, but I did happen to use my personal device to get into systems, was compromised? Like, what if all of the information they have, because now they have the ability to look at my screen, to use my camera, to record things, all of this could be used in order for somebody to take that information and access the company later, because my device still has access to it. Hopefully that made sense. And finally, what code is running on your system? We keep talking about what applications and what are we doing, but one thing that all effective cyber attacks that are able to compromise our environments and exfiltrate data, turn it into a bot, turn it into a crypto miner, share, they have to execute code. I know that it's maybe an unpopular thing to say, but you could have all of the backdoors that you wanted, and probably don't want it, but all of the backdoors in the world. Your system could be just a cheese grater at this point. And if nobody ever went into your system and executed any code, does it really matter? Now, I'm not telling you to do this, but we have to understand what code is running on there so we can understand, is there actually malicious code occurring? Like with Cloud Snooper, everything looked fine. But in the end, things were happening that shouldn't have, and that was code within the system. Okay, so let's go with, it's all about, yeah, I couldn't help myself, all right? I wish I could sing, I really do, because that's what I want you to understand, is it doesn't even always have to be malicious code. It can be unauthorized code. You know, we're talking about living off the land attacks. A lot of times people speak to these as, well, that's what we're looking at when we have things like anomaly-based detection, which I guess technically fits with that. You know, we're looking for patterns that, you know, are things happening that shouldn't be. Yes, but what if it might look right, but then it isn't? That's exactly what you saw when it came to Cloud Snooper. And as I'm talking, I'm remembering new examples, so y'all just run with me. But there was a recent new piece of malware that was found that was called RedXOR. RedXOR was very successful because it was able to hide itself as a Polk KD daemon, and it was doing everything that you would expect, right? It's running in the background, it has root privileges, it's communicating out as one would expect, except it's also bringing in code that it probably shouldn't. It's executing that code, but it's behaving exactly the way that you would expect that system to look like. And so you need to understand, you know what, if you see something that's a living off the land attack, is it actually something that can be trusted? And you know what, like, attackers aren't going to name things like, hey, this is a minor, this is whatever. I just did this because it's easier for me to show you. But you need to see what's actually running on the system at that time if you do have an attack. One of the biggest issues that we're having right now is things like fileless malware. There is nothing on disk for us to be able to investigate. And what happens in the cloud? You know, we either Windows the issue, turn the server on, turn it back off again, and then we wipe everything out. Or in the cloud, we have automation set up to, you know what, that server really isn't acting the way we want to. Just delete one and put it in its new place. And this isn't even a decision that we're making. We're completely automating this process, which makes it take even longer for us to actually see, for us to have that visibility to there's actually an issue. It's not till we've seen maybe the 100th alert within a team or somebody's going like, why do we keep getting these? I know that I'm making the company I used to work at look horrible, but I promise, like, it's across the board. It's not just this one. But we would get alerts like, oh my God, you know, high CPU usage, high proc, you know, usage, and it would clear out, and we'd be like, it's cleared, whatever, and we just move on. It wasn't until about like the 50th time that you start going, you start recognizing that server that you're going, you know, it cleared, but I should probably look into this. If they're hiding their attack correctly, how long could that actually take? How long could they already be in that system and have pivoted into other systems before you even realize that it's occurred? Okay, I want to make sure to leave time for questions. So let's go to my actionable suggestions. Okay, patch your systems. Yeah, you know, yeah, patch your servers. And some of you may be laughing, going like, really? That's the advice we're going to give you. Everybody gives that. We know that. If you know it and you've been told it before, then why are we still being compromised almost on a daily basis for servers and environments that weren't patched? It is not the cloud's responsibility to patch your stuff. I wanted to say another word there. You might have the agreement that is, you might think that it is, the buck stops with you. Make sure that those servers are patched, make sure that they're up to date. If they're not, then you, your developers, your company, need to have a serious conversation about this issue. Because I've heard, oh, well, it can't be patched because it'll break this application and this is mission critical. What I hear when you tell me that is this vulnerability is mission critical for our company to work. When you phrase it like that, do you see what the issue is? There has to have serious conversations that occur, not only on how we can mitigate this by, you know, updating the application in this long term. What is our plan right now? If we assume that there's already an attacker there, or there's already an attacker specifically going for that resource. Patch your stuff. That's where I'm going. Patch it, and patch all the things. Have I said that enough times? When we spin up servers in the cloud, we're like, okay, hey, it's a brand new image. I just spun it up. Their image is obviously up to date because this is what they do for a living. I spun up a web server, and then I went looking for what the problems with it was. Yeah, I had quite a few libraries that had critical CVEs and a lot of them on highs, and I literally ran the scan within minutes of the server being up. Breathe out. All right, here are your actual steps. You need to assume breach. The wolf is already in the castle. You can build all the walls that you want, and that's currently our strategy. You need to go hunting. You need to know what resources you are. Where are you hunting at? You need to know what code is being used. Where are those wolves going? What are their intents? Who are they hunting after? Are they hunting after, I don't know, deer or chicken? Whatever. It's going to impact the way that you approach things. And know your configurations. It's not just all about the deployments. It's not all on the developers. We need to work together. This fallacy of DevSecOps needs to become reality. I've sat down with teams before that have told me the decision is eventually made that either it's come to market because we've said, hey, we're going to release this function on April 3rd. April 2nd comes, the code isn't quite there. Are we going to lose more money if we don't put out this function and fix it later in production than we would if we were compromised? Like, these are budgetary decisions that are being made that should never have to be made. I'm not saying not to do your pre-runtime scanning. I'm not saying don't do your firewalls. I'm not saying don't use any version of antivirus. I'm not telling you to stop the good things that you're doing, but I'm telling you to take a big look into those and see what else is missing, what you don't have visibility into. And finally, my last suggestion, and this might be the one that all of you love the most. What's missing is really our abilities to keep up with what the company is looking for. For us to, and you're gonna get tired of hearing this, but you're gonna remember it, for us to have visibility into what, excuse my language, I'm gonna go with hell, what the hell we are supposed to be protecting, what the hell we're supposed to be using. We need to train our security professionals to have the ability to keep up with what the latest products are, release cycles, and things that are changing. We need to have not only the, oh, we have these resources available, but we need to have dedicated time to learning what it is that we're working with. And at the same time, to have the tools that we need to be successful and training on those tools. All right, here's my summary. I'm almost done. The wolf is in the hen house and it's time to go hunting. Please note that this is not an endorsement to actually hunt wolves. With that being said, hopefully I've left enough time for questions, and there is the link to my slides and additional resources that I have. Thank you all so much for having me here.